5 ways modern car engines outshine their predecessors.
Most car engines work on the same principle. Combustion of fuel and air creates rotational forces that move the car. A car's engine has mostly stayed the same compared to other technologies. Alexander Graham Bell probably wouldn't know how to use an iPhone. Although communications technology has evolved dramatically, car engines still use the same fundamental principle: combustion of fuel and air to create rotational forces and move a vehicle. Modern car engines have evolved to meet drivers' needs today. Imagine older engines as wolves and modern engines as dogs. Both share the same history and similar characteristics. However, one can adapt well to everyday life, while the second cannot. You need to know the basics about car engines before understanding how they differ from older models. In a chamber known as a cylinder, gasoline ignites with air. The gasoline-air explosive movement moves a piston in the cylinder. The piston connects to the crankshaft. The crankshaft is rotated by the piston moving up and down. The power from the crankshaft is sent to the transmission, which then transmits it to the wheels. It sounds simple. Modern engines still have the same basic principles but are more complex. This video will explain the 5 main differences between modern and older engines. Please subscribe and like my channel while you are at it to be notified of new videos. Five ways that modern engines are different from older engines. 1. Modern engines are more efficient. 2. Modern engines are more powerful. 3. Modern engines are smaller. 4. Modern engines work smarter. 5. Modern engines have partners. Having mentioned the 5 ways modern engines outshine their predecessors, please pay attention while I elaborate on them one after the other. 1. Efficiency. Modern engines are equipped with various technologies that make them more efficient. The basic gasoline engine in your car is not very efficient. Only 15% of the chemical energy contained in gasoline is converted into mechanical energy to move the vehicle. According to the EPA, over 17% of energy is lost when the engine is idle. A staggering 62% of that energy is lost due to heat and friction in the engine. There are a variety of technologies that modern engines use to increase their efficiency. Direct injection, for example, mixes fuel and air before they are put into the engine cylinder. It can improve the engine's efficiency by 12% because the fuel burns better. Source: U.S. Department of Energy. Turbochargers that use compressed air from a car's exhaust system compress the air used in combustion, and compressed air results in more efficient combustion. The engine can use less fuel using variable valve timing or cylinder deactivation. It's a misconception that efficient engines have low power. Watch to see how modern engines can outmuscle their older equivalents. 2. Modern engines are more powerful. Even though they are more efficient, engines today are still more potent than their predecessors. Fuel efficiency is more critical now, but engine power is also more important. Horses powered the first cars. Today, cars are driven along freeways. Modern vehicles are heavier because they have more safety features. The engines of today's cars have to perform a lot more. They are carrying heavier loads and moving faster. Despite their improved efficiency, modern engines are still more potent than those of the past, even when compared with engines just a few short years old. In 1983, a 3.8-liter V6 engine powered the Chevrolet Malibu and produced 110 horsepower. It had a 2.2-liter 4-cylinder engine in 2005 that produced 144 horsepower. The base engine in the 2011 Malibu is a 2.4-liter 4-cylinder that produces 169 horsepower. A 3.6-liter engine with 252 horsepower is also available. The V6 in the 2011 Malibu, although smaller than the V6 available on the 1983 model, produces 146 more horsepower. The Malibu's current 4-cylinder engine has 59 horsepower, more than the V6 of the 1983 model. 3. Modern engines are smaller. The car makers now know they can maintain the engine's power to satisfy consumers' needs. You'd expect modern engines to be more significant because they produce more power. If you look at the Chevrolet Malibu engine we used previously, you will notice that engine power has increased while engine size has decreased. Attributing the shrinking engines in modern cars to increased efficiency is possible. The carmakers learned that increasing the engine's size is unnecessary to satisfy the needs of power consumers. It's enough to make the engine smarter. Modern engines are more efficient because of the technology. They can also produce more power without needing a more extensive package. Ford F-Series is the best example. The 2011 Ford F-150, long the most popular truck in America, and sometimes the best-selling vehicle period, is an excellent example of how a smaller motor can do the same job as a bigger one. The 2011 F-150 comes with an optional 3.5-liter engine that produces 365 horsepower. The 5.0-liter V8 engine is available and makes 360 horsepower. A larger engine will always have more power. The F-150 comes with a 6.2-liter engine that produces 411 horsepower. It is a far cry from the 3.5-liter. It is impressive that a V6 can match the power of a V8. Expect smaller engines to take on the tasks once done by monster V8s as consumers demand better fuel efficiency. 4. Modern engines work smarter. The cylinder deactivation system allows certain cylinders to go off when not required, such as when the vehicle is idle or on cruise control. Modern car engines are less potent than older engines. The old V8 engine had all 8 cylinders firing whether the car was idle or accelerating to its maximum. All 8 cylinders received the same amount of fuel regardless of the work done by the engine. Engines today are more intelligent thanks to technology. Cylinder deactivation allows certain cylinders to shut down in an engine when they are not required, such as when the car is idle or on cruise control. These cylinders will wake up when more power is needed. The deactivation of cylinders helps engines run more efficiently because it only uses needed fuel and extends only the effort necessary for the task. Modern engines can also be more intelligent using variable valve timing, lift, and other technologies. The engine's valves would open the same length of time and at the same distance, no matter how hard it is working. This wastes fuel. The valve openings can be optimized to the type of engine work with variable valve lift and timing. It helps the engine operate more efficiently and uses less energy. 5 modern engines have partners. Hybrid cars use electric motors powered by batteries to assist their modern engines. Modern engines are well equipped with several technologies that help them use less fuel and produce more power. But they also have something that older car engines still need: partners. Today's engines aren't just sophisticated technological advances paired with high-tech components to help them perform better. In the past, people considered cars with 4 or 5-speed transmission to be cutting edge. Today's engines come with transmissions that have 7 and 8 speeds. Transmissions with more than 4 or 5 speeds are better able to match engine power and make the drivetrain more efficient. Modern engines can be paired with continuously variable transmissions if 8 rates aren't sufficient. CVTs can have an infinite number of gear ratios. It allows them to transfer the engine's power to the wheels as efficiently as possible. Hybrid cars use electric motors powered by batteries. The electric motor powers the vehicle when driving at low speeds or running accessories while the car is parked. You can also use it for extra power during acceleration. The electric motor will make the car's engine smaller and more powerful. It saves fuel. Some car manufacturers combine electric motors and powerful engines to boost performance. Here concludes this video. Please leave your comment, like, and don't forget to subscribe to my channel to see more videos.